Okay, so we're going to go over the last three examples in your packet. And the first thing we have is the region in blue. It would be gray on your handout, bounded by the line y equal x. Here we are, and sine x, that's in red. And we're going to start our setup. We're told that the limits of integration are 0 to pi. So we're going to set up our integral. I'm going to use a very thin rectangle to represent our height and our width. Our height is the difference between the two functions, f and g, so that will be x minus sine x. And our width is dx. And so the definite integral represents the infinite sum of all the areas of those rectangles. And we're going to evaluate our antiderivative. So we'll start by taking the antiderivative of x, which is half x squared. And our antiderivative of sine is negative cosine x. We're going to evaluate this from 0 to pi. So we'll have half pi squared plus cosine pi minus half of 0 squared plus cosine 0. And I'm running out of room. Let's see if I can move this up a little bit. Oops, we're getting into the next question. Move it up and we'll continue to evaluate. We have half pi squared. Cosine of pi is negative 1. We're going to take away 0, and then we're going to take away the cosine of 0, which is 1. So our area is pi squared over 2 minus 2. Okay, the next region we are going to evaluate, this is actually the last one, I flip-flopped the problems. We're going to use our calculator to evaluate this. We'll start by drawing in a representative rectangle. I'm going to do that in blue. So here is our little rectangle. The reason I do that is because I want to make sure that the rectangle is continuously bounded by the same curve across the top and the same curve across the bottom. So I can see, and it's given to me, that my limits are 0 to 2. The height of my rectangle is root x squared plus 2 minus 1 over x plus 1, and the width again is dx. And we're going to use our calculator to evaluate this. Let me grab my calculator. And when you guys go in, you're going to go to Math 9 in your graphing calculators. And if you have an updated operating system, Math 9 literally takes you to something that looks like this. And you're just going to enter in the appropriate information, 0, 2, your integrand, and x. Otherwise, you might get something that looks like this, in which case you need to enter in 4 parameters. The first parameter you're going to enter in is your integrand, and you need to parenthesize your integrand. You're going to put a comma there. The second parameter is going to be x. You don't need parentheses around that. Third parameter is 0, and the last parameter is 2. Close off your parentheses, and you're going to get your value. And you should get 2.349 as the area of that shaded region. Okay, our last example is the area bounded between our quadratic and our linear. I'm going to draw on that representative rectangle. And you can see my rectangle is always bounded on the top by the quadratic and bounded on the bottom by the linear. Our limits of integration are already given to us. If you don't know the points of intersection, you need to find the points of intersection. So we're going to set up our integral from 0 to 4. The height of our rectangle is 5x minus x squared minus x, and our width is dx. I'm going to do a little simplification, not necessary, but you may want to. And we're going to evaluate. So the antiderivative of 4x is 4 times x squared over 2. And the antiderivative of x squared is 1/3 x cubed. And we're going to go from 0 to 4. So let me do this. That'll reduce out. So we have 2 times 4 squared minus 1/3 of 4 cubed. And then when we evaluate this polynomial at 0, we're going to get 0. So our area is going to be 16 times 2 is 32 minus 64 thirds. And 32 minus 64 thirds is 32 thirds.